Hello. I hope you've been having a great day, whether this is in the morning or in the afternoon. I hope I am as well. We have a track meet. It's supposed to be raining today. Kind of secretly want the rain because I love the rain, but anyways. Okay, we are working on scatter plots, and as I introduced yesterday, a scatter plot is showing the relationship between two quantities. Now, sometimes they don't have a relationship. For example, your favorite music genre and the number of legs with 8 dogs. I don't know, something like that. Things that have nothing to do with each other, okay? That doesn't have a relationship. So a scatter plot's not necessarily going to be the greatest way to interpret that information. So you're really looking to use a scatter plot for something that has a relationship, even if it's positive or a negative relationship. And yesterday when I was talking about the graph of the scatter plot, and we said, does it look more like a line or more not like a line? Because what it is, it's all these data points, right? And you are trying to do things with that data. Now, the things that we're going to do is we're going to analyze it. We are going to use an equation that we're going to learn how to do today and do things like predictions with this information that we have showing the relationship between these two quantities. So yesterday I talked a little bit about the gray and slapping something black and white. What I mean is we're using information that is, almost never linear, right? And we're going to try and slap a linear model on top so we can do those things with it. So the equation that we create today is not going to be exact because the difference between every point is not going to be the same, okay? It's just a good representation of that relationship. So here we go. 9.2. Lines of fit. All right, there is only one problem we're doing today, but this one problem has a lot of parts. So let's define a line of fit. So line of fit. Okay. What it is, it's a line, a line drawn on a scatter plot as close to as many data points as possible. What it is, it's used for estimations on your data. Okay. So line of fit, it's a line that you're going to draw. Can you actually draw a wrong line? Yes, you can. And there's ways on how we go about drawing a good line of fit versus a bad line of fit. You're going to learn a little bit later down the road what a best line of fit is, which is a little bit different than just a line of fit. So we're going to be drawing some lines today on top of a scatter plot. We're going to be writing equations, which we've now done 3 separate times this year. And that equation is going to be in our best friend form, which is slope-intercept form, y equals mx plus b. So if you need a reminder about that form, go to chapter 4, like 4.5-ish, something like that. If we were in class, I'd say, oh, you are in class. Go look at the center of the wall, the turquoise wall. Y equals mx plus b, right in the middle of the wall, right in the middle of it. Okay. Here we go. Example 1. So hopefully you're following along in your book, because that's what I'm going to be referring to. So it says, the table shows the depth of a river X months after a monsoon season ends. Okay. Do you guys know what a monsoon is? We don't really have them here. So a monsoon is heavy downpours of rain in a very short amount of time. Arizona tends to get them. I've been stuck in a couple monsoons over there. I don't know where else has them, but I know we don't have them, but Arizona does have them. So it's a lot of rain very quickly, and that's monsoon season. You're going to make a scatter plot of the data and draw a line of fit. You're going to write an equation of line of fit, interpret the slope and y-intercept, and then predict. So we got a couple things going on with this information. Now, in example 1 of the book, 9.2, and I'm pointing over here because I'm looking at my book, okay? So the table that we have, we are going to plot all those points, okay? So I'm going to write down everything we're going to do here. We're going to write down the information the problem gave us. The table shows the depth of the river X amount of months after a season ends. So X is months after monsoon season ends. Okay, that's X. And then Y is the depth of the river. So let's think about the depth of the river, logically speaking. So we understand it with all of our snow melt. Okay, when the snow melt is coming in, our rivers get much higher because of all the water. And then as it dies out, as the more snow melts and melts, as it's tapering off the snow melt, less water is coming down. So we're gonna, if it helps to think of it that way, think of it that way. It's like, after the snow melt season, that kind of a thing. So the more months that go on after the monsoon season ends, your river should be getting lower, not higher. The only way your river is going to get higher is if you have downpours of rain that keep going, right? That are continuous, not just after a season ends. Okay, so that's information. We're going to make a scatter plot. Make scatter plot and draw line of fit. Okay. Make scatter plot and draw line of fit. Now I'm going to be moving a little bit faster, so hit that pause if you're not there. Okay, so you're going to do that. I just happen to have made a graph over here. Ta-da! So in your notes, draw an L, so it's first quadrant. You're going to go at least 9 on your x-axis, and we need to go up to 20, because in the table, it's 20 feet is the highest number, okay? So I already did it here. I went by 1s on my x. I also went by 1s on my y, but I only called up every 2, okay? So go ahead and hit pause. Go ahead and do this, but I'm going to get going on this. Once you're ready, then re-hit pause, okay? Don't forget your labels, months and depth. So we're going to plot those points. So 0, 20. So 0 all the way up there. That's your first point. 0, 20. 119. 215. And I'm just looking at the orange table in example 1. So you've got to have your books out. Okay. So I just did 215. I need 313. 313. 411. 11, 5, 10, 6, 8, 7, 6, 8, 7, 7, and 8, 5. Okay. So I just plotted all those points from the table. That's all I did. I just looked at the table and I plotted those points. Okay. Now part A says we are going to make a scatter plot and draw a line of fit. So our scatter plot is made. Voila. Okay. And even though it's not asking us to, let's just look at it. Is it more like a line or more not like a line? Hopefully you said more like a line. Okay, so it's going to be linear. Linear. Now, is it generally rising or generally falling? Hopefully you said falling. So now we have, this is going to be a negative linear relationship, meaning as x increases, y is going to decrease, and that's exactly what our graph is showing. All right, now it says to draw a line of fit. Okay, now drawing lines of fit, it actually takes a little bit of skill because it's not as easy as you want to because you're so in tune with connecting all the dots. That's all you've ever done, but you don't want to do that. If your line goes through some points, that's fine, but you don't want to purposely go through and play connect the dots with everything. So how do you do this? Okay, this is gonna be a little bit weirder because I'm on small board. So what I do is I look at where I'm gonna draw, okay? And since you're gonna go for your first point, so you're gonna go from top to bottom. And I'm gonna look where I'm gonna go. Here's what I do. I do not put my pen down, okay? I don't do it until I'm ready to draw. And you're gonna look to see where it goes. Now, the whole point about a line of fit is you wanna get this line as close to the data points as possible. So, let's see if you guys can see this. I'm gonna turn it a little bit just because of the angles, okay? But I'm still going this way. I'm just tilting it this way, just easier to hold. So here we go. There we go. I think that's pretty good. That's pretty good, I think. Here's how I know I did a good one. Because I have some points that are above it, some points that are below it, and I have a line that goes through some of the points. That's actually probably the best line of fit I have ever drawn. All because I'm on a coordinate plane. Now, here's what would be a bad one. So let's say you're drawing this, and don't do this on yours, just watch mine. Let's say I'm drawing, and I'm like, oh, way down here. This is nowhere near any of your points. No good. So that would be a redraw, okay? So let's say you're looking, and you're looking up here, and you're like, oh, it's close to those two, which is not bad, but it's nowhere near any of the other ones, okay? So that's bad too. How can you get one actually wrong? Something like that. Something that does not even describe your data. This line is describing a positive relationship as x increases, y increases, which that is the exact opposite of what's happening here. So this is actually how you get something wrong. Like, what are you thinking? Okay. All right, so that's my line of fit. I'm quite proud of that line of fit. That's crazy. Okay. All right, part B says write an equation of the line of fit. Okay, so back over the big board. B. Write equation. Okay. And hopefully you put this under that, right? Because you don't have like two composition books you're using. All right, so equation. We're looking for y equals mx plus b. Why? Because that's what we always use when we're talking about a line. So you need to do two things. You need to find your m and you need to find your b. So m is your slope, b is your y-intercept. Find m, find b. That's what you got to do for any writing equation. So how do you find m if these points are not on the line? Because remember, your data is what I call the gray material. You're slapping something that's black and white on top of it. You're slapping something that's in factual linear, as in this and this and this and this and this. This is exactly the same when it's not. So what do? So here's what you're going to do. I always suggest, based on your line of fit, grab 2 points that are close to each other, or grab 2 points where your line goes through. Okay? My line actually went through quite a few. So I could use maybe these 2 points or these 2 points. Even these 2 points are good because these two, even though my line didn't go through this point, they're still pretty close. And my line is going through this point and it's just missing that one. This is a good set. That's also a good set. You could even use this set as well. Okay? Because there's not going to be one exact answer. And that's the hard part about lines of fit, is because there's more than one answer. And in math, we like sometimes just one answer. But this is not going to do it. You're going to have more than one answer because it's based on your personal line of fit. Okay? So, this is where I ask you guys what points to use. So, I'm just going to grab this one and that one. Those are the points I'm going to use. Okay? But if you want to follow along with me, then you're going to use my data. I would prefer that you picked your own points based on your drawn line of fit. All right, so that is 6, 8. So 6, 8. And then I had 7, 7. 6, 8, and 7, 7. Okay. So you are not tracking on this graph. You can't do that because it's not the same between every point. So we're going to the formula. So m equals y2 minus y1 over x2 minus x1. Formula. We're finding m first. Label it x1, y1, x2, y2. Just when you thought you were done. We're not doing anything new. We're just kind of, doing it again. Here we go. Plug it in. So you should have 7 minus 8 over 7 minus 6. Okay. Which is negative 1 over 2. All right. Oh, that's funny. I'm just looking in the book what 2 points they used. They used 5, 10, and 7, 7, which is okay. That's totally fine. Okay, so now my slope is -1/2. If you look in the book, they use 2 different points. They use 5, 10, and 6, 8, and they got a slope of -2, which it's still close to -1/2. Okay, something that would be far off, -10, -5 would even be too much. Okay, so that's why I'm saying there's going to be multiple answers based on what 2 points you chose. All right, so I have M. I need to find B. You're given a graph. There's 2 ways you can find B. You either look at where, sorry, that might have been a little scary. Look at where it's crossing the y-axis, pardon me, x-axis is algebra, sorry. You look to see where it's crossing the y-axis, or you look for the coordinate where x is 0. Here's your graph. Do you have a point on the y-axis? It's right here. Is there a point in the table where x is 0? It looks like this. Okay, so you've now identified B. B is going to be 0. Okay. Oh, goody. So you have B equal to 20. All right. So you have M, you have B. You're going to put it into y equals mx plus b. So you have y equals -1/2 x plus 20. Okay. Their equation was y equals -2x plus 20. It's still good. If you had, let's say you chose different points and you had a slope of -1, that's still good, okay? Because remember, this is not exact. It's not precise. It's just used for estimating things. That's why you can have multiple answers, okay? So tomorrow when I go over these, I'll say, okay, what other slopes do you have out there? And you'll give me like, I don't know, -3 or whatever. I'm like, okay, what points did you use? You'll give me the points. And I'll tell you if you're correct or not, okay? So multiple answers. And so that might be where it gets hard when you are working on this with someone else, because they may choose different points because it's based on their line of fit. All right. We just did B. We wrote an equation of the line of fit. So we're using y equals -1/2 x plus 20. Part C, interpret the slope and the y-intercept. Okay, I'm going to come up here and erase this. I just need more room. Okay, so C, I can't see all the way up there. Interpret the slope and y-intercept. This is the hardest part because we don't do it much and we don't get a lot of practice of it. Okay? Because when you interpret something, you're putting it in a different language. So you're interpreting numbers into words. You're putting meaning behind what these numbers mean. So M is -1/2. The book is -2. That's okay. So you would actually be interpreting -2 over 1. If you got a slope of -1, it would be -1 over 1. Because you need your rise and your run. Pardon me. Because this is a real life situation. And in real life situations, you have something on your x-axis and something on your y-axis. There it is. Okay? And B is 20. But it's an intercept. You have to use your 0. So it's not this guy. It's actually 0, 20. Another reason why I make you use the 0 every time. Okay? All right. We got to figure out how to do this. So M equals -1/2. That is your rise over run. And it's also known as y over x. Okay? And I just erased it. But if you look at your graph, y, what's my y-axis called? The depth. Okay? So we're talking about depth of river over, what's my x-axis? Month. But remember, it's months after the season ends. Months after season ends. And I'm writing all this because it's going to help me put that into words, because I'm just going to substitute number in here and number in here. Okay. All right. Almost done here. So we now have this all equals -1 over 2. So the depth of the river is -1. That doesn't make sense. Well, it's not supposed to make sense because you can't have a negative depth. But what you can do, remember, you're talking about depth of the river in feet. So what you can say is the depth of the river drops a foot. It loses a foot. It's, 1 foot less than it was in 2 months after the monsoon season ends. That's what that means, okay? So we got to put this into words. So something like, for every 1 month, for every, we want y over x first. The depth of the river is going to drop a foot for every 2 months, okay? The depth. Now, those are my words, okay? Say any way you like, as long as you're talking about the depth of the river is decreasing. It can't be increasing because that would be a positive one, but it's got to be decreasing. So the depth of the river, you can even say drops a foot. I don't care, but you gotta somehow use words that tell me that you understand that it's no longer as high as it used to be. The depth of the river, drops a foot, whatever, drops a foot. Decreases in foot, drops foot for every 2 months after the season ends. Okay, so that's over here. So I put it right next to my slope. The depth of the river drops a foot, because that's 1, for every 2 months after the monsoon season ends. Drops a foot for every 2 months. So if your slope was, let's say, m equals -2 over 1, like they had in the book, you would say it drops 2 feet for every 1 month. Okay? Which, if you think about it, 2 feet for 1 month and 1 foot for 2 months, they're the same. We're talking about the same. It still drops the same amount. Okay? In 2 months. All right. If it was -1 over 1, the river drops a foot for every 1 month. Okay? So we got the M part. Now we got to do the B part, which this one, you have to talk about your 0. Okay? So B is 0.20, and that's X. That's Y. Okay? What does X represent? Months after the monsoon season ends. What does Y represent? Depth of the river. So if we want to say 0 months after the monsoon season ends, it's kind of a weird way of just saying, hey, when the monsoon season ends, the river is going to be 20 feet deep. You have to talk about that 0. So when the monsoon season ends, someone last year said something like, at the start of the end of the monsoon season. Isn't that kind of wordy? But hey, it worked for them. So when the monsoon season ends, I prefer that, the river is 20 feet deep. There you go. When the monsoon season ends, it's 0 because it's no longer having these torrential downpours, okay? Or 0 months after the monsoon season ends. However you want to say it, guys. This is what makes sense to me. When the monsoon season ends, the river is 20 feet deep. That is interpreting. You're changing from one language of numbers into words, okay? So, yeah, translate is going from one language to an X, and sometimes our languages are numbers. Okay. We don't get much practice of this, but just think about, put the numbers in meaning. No, I don't like how I'm going to say that. How about you say this? When you interpret something, you're putting meaning behind what the numbers mean. Putting meaning behind the numbers, is that better? Oh, it's been a long day. Anyway. All right, last part. It says, part C. Nope, I already did that. Like I said, it's been a long day. Part D. Gosh. Predict the depth in month 9. Predict depth in month 9. Okay. Let's do this 2 different ways. One, we're going to look at our graph. Okay. So, good predictions of depth at month 9. Okay. So you could go up from 9 up to your y-axis and go, you know what? That looks pretty good. Follow it over. You know, it's kind of close to 4. Okay. That'd be a good prediction. Even if you said 3, that'd be a good prediction. If you said something like up here, that's a bad prediction, and that would actually be an incorrect answer, because what you're saying is the water is decreasing, and then all of a sudden it gains a bunch of more feet. Not this far out after the rains have stopped. Okay, so yes, you can get things wrong because you're making a bad prediction. Okay, so a good prediction would be something like, it could be 5, even though we already have a data point at 5. Let's say they didn't have any more rain. Okay, or maybe they got a little bit, but it wasn't a monsoon. I don't know. There's all kinds of things they can come up with. But 4, 3, 2 might be a little too much, because that's where 2 would be. Be a little bit behind your line of fit. Okay, so I would say around 4, 3, 4-ish would be a good one. Okay. Now, here's the thing. Here's the other thing you can do. You use your equation, and that's normally what you're going to do in real life situations. Because when I was telling you guys yesterday about when I used this in forestry, we used the equation. We didn't just look at graphs. We had to use the equation. You're going to find out why much later. Algebra, lines of regression, stuff like that. Okay, so I'm going to use y equals, where's my equation? -1/2 x plus 20. I erased it. Okay, so now what do you plug in? So we want month 9. And look up here. X is months after the monsoon season ends, which is month 9. So this is X right there. X is 9. And you're going to substitute that in. So y equals -1/2 times 9 plus 20. You're going to plug 9 into the equation for X, because X stands for the months after the season ends. This is a long video. Okay, and just do some math. What's half of 9 and then make it negative? Half of 9, -4 1/2 plus 20. Here's why we do it this 2 ways. Okay, -4 1/2 plus 20. I do not like this. Y equals 15 1/2. That is using my equation. That's why we started with the board. Month 9, 15 1/2. Good Lord, that's not a good prediction. Okay? So that's why you want to take a look at your graph first to get a good eyeball prediction. But then also, yeah, you do sometimes want to do the math as well. Okay? Get in the habit of doing both, because using the equation does not give me a good prediction. But using the graph does, because look at this prediction way up here. That's just stupid. Okay? That's a much better prediction. Okay? So you can't always rely on equations to make sure that you're going to get a good prediction, which that's the whole point of a line of fit. And writing an equation is we're going to try and do something that's not linear, meaning all this data is not linear, and we're slapping this linear model on top so we can do things like predictions and analyzing more data. There's more things that we could do with this kind of stuff. Okay? So use your common sense first. Eyeball the graph. That's good. So not good. But this is what that gave us. All right? that's what we're doing today. I'm only doing one example because as you can see, there's a lot of parts to it. So lines of fit, reviewing your equation. Oh, that's part C. I forgot I erased it all. How to make an equation. Got to find M. You got to find B. Okay, don't forget about that. That comes from chapter 4. Check out your foldable if you need help. Okay? If you have questions, of course, you'll be able to ask me questions when I get back. But I hope you enjoyed Lines of Fit. I'll catch you later. Toodaloo.